Hello everyone, welcome to the linear regression analysis with rapid-minded tutorial. This is Reza Vaezi and this tutorial is loosely based on Dr. Matthew Norris's book, The Data Mining for Masses. Okay, let's start by importing the data, and as I do that I will talk about the business and data understanding for this analysis. Okay, the first dataset that we are going to work with is called the training dataset. Remember that regression analysis is a predictive type of analysis in a rapid manner or supervised type of analysis. And when we are dealing with predictive or supervised, we are dealing with two sets of datasets. One is the training data, another one is the scoring data. Let's go ahead and import the training data. The training data is the data that is used to train the computer, is used to train the algorithm to learn the patterns, and it can use those patterns in predicting what we are interested in our scoring data. The main difference between the training data and scoring data is that the training data includes or contains the target variable or the variable that we want to predict, but the scoring data does not contain the target variable. Now let's go ahead and just import this data. I will talk more about it once we are in the metadata screen. I'll just leave the name alone, linear regression heating oil -T, which is short for training. Okay. Now let's take a look at data and let's understand our data and the business purpose behind this analysis. You are somehow familiar with this dataset as we used it for our correlation analysis. So as you remember, this data is coming from a retailer of heating oil, and it contains few variables. It contains installation, temperature, heating oil, number of occupants, average age, and home size. Installation is a density rating that ranges from 1 to 10. A home with density rating of 1 is poorly insulated, while a home with density rating of 10 is in excellent insulation form. Temperature is the average outdoor ambient temperature at each home for most recent year. And heating oil is the total number of units of heating oil purchased by the owner of each home in the most recent year. Number of occupants is the total number of occupants living at each home. Average age is the average age of those occupants, and home size is a rating on a scale of 1 to 8 of the overall home size. The higher the number, the larger the home. So we have this data that is from our last year and current market. This company is about to enter a new market, and we want to predict the heating oil usage for that market. We have all the information regarding the residents of the new market, but we don't really know how much heating oil they are using or they are going to be used. So we can use that in our distribution planning, and we can use that in our purchasing orders. So when we want to put the purchase order from our refineries, we can have a good estimate how this new market, what would be the demand for this new market. So we want to use old data, historical data, to be able to predict the demand for a new market that we are entering. For that, we are using our current data, and we are using the data that refers to our last year, the heating oil sales of last year. And the last year data is called training data. We want to use that training data, the last year data, to train our algorithm, to train our model, and then apply that model onto our current data or the data for the market we want to enter in order to predict the demand, the heating oil demand in that market. Now, as you can see, there is no missing value, and all the data that we have is well within the range, well within the expected range. Now, let's go ahead and start building the regression model. Let's go ahead and drag and drop this data set into the process window, and then we can start looking for the operator that is used for linear regression modeling in RapidMiner. Let's go ahead and search for it. We can search for regression. You have the linear regression. Let's go ahead and drag and drop it into the model. Now let me connect this one to the linear regression. As you can see, as I connected my dataset into the linear regression operator, I still have an error here. Let's go ahead and hover above the error and see what's going on. Okay, it says input example set must have a special attribute label. So what does this mean? It means that in order to use linear regression, which is used for predictive modeling, you need to tell this operator about your dependent variable, your target variable, or as RapidMiner calls it, your label variable. And that's the variable you want to predict. What do we want to predict? We want to predict heating oil usage. So we need to tag heating oil or give the heating oil the role of label or the role of target. How can we do that? There are two ways of doing it. You can either do that at the time of importing the dataset, which I didn't do it, or you can do it later using an operator called setRole. Let's go ahead and use setRole. So what was our label again? The variable that we want to predict was the heating oil usage. We want to predict the heating oil usage in our scoring dataset. But the heating oil usage already exists in our historical or in our training dataset. And the linear regression will use the historical dataset or the training dataset to learn the pattern and to form the equation that you've seen in the lecture, the linear regression equation, based on the already existing data. Now let's go ahead and set heating oil as label. You can see that as I define heating oil role as label, the error will go away. As soon as you define it as label, the error will go away. Now the linear regression operator has what it needs. It needs a dataset with a label variable. And let's go ahead and connect the model port to the results port and run this basic model. Now what this will do for you will go ahead and create a linear regression model using your old data. It will use the heating oil as the dependent variable and the rest of variables, installation, temperature, number of occupants, average age, and home size, as independent variable. We believe that these independent variables, installation, temperature, number of occupants, average age, and home size, determine the values for the heating oil. They have an effect on the heating oil. At the same time, when we call these independent variables, we are also assuming that these variables are independent from each other as well. They are independent from your dependent variable, and they are also independent from each other. In linear regression, if there is high correlation between your independent variables, you will run into a problem called multicollinearity. Multicollinearity will affect the validity of the results of regression. I'm not going to get into this discussion, but if you ever run regression analysis, you have to make sure that there is no high correlation, there is not high dependency or high correlation among your independent variables. If there are such high correlation, you need to study up and figure out how you can deal with the problem of multicollinearity that is affecting the validity of your results. Okay, let me go ahead and run this. And here is our linear regression model. You can go ahead to the model description and see the model. So this is like y, or your dependent variable, is equal to this intercept plus b1, x1, b2, x2, b3, x3, b4, x4. That's your regression equation. Now let's go ahead and take a look at data a little bit better. So you can see the coefficients. You can see standard error, standard coefficient, tolerance, t-test, p-value, and code. Determining whether any of these readings are valid, you need to look at the p-value. The p-values smaller than 0.05 indicates less error or a tolerable error in estimating the coefficients. You don't want to include any variables with the coefficients that their p-value is above 0.05. You always have to make sure it's less than 0.05. Also, the code is related to the p-value. As you can see, for all these p-values which are 0, we have 4 stars. If it is between 0 and 0.01, you will get 3 stars. If it is between 0.01 to 0.05, you will get 2 stars. If it is between 0.05 to 0.1, you will get 1 star. You always want to have the code of at least 2 stars. So you will see in your assignment that some of the values, some of the p-values are above 0.05. What you need to do, you need to exclude them from your analysis. You need to exclude them from your next round of analysis when you run the model one more time. Let's take a closer look at this results as well. Can you identify any missing variables, any missing independent variable? If you look closely, you can see that the number of occupants is not within this regression analysis. So what does it mean? It means that the linear regression could not find a number of occupants important to predicting heating oil usage. And it means that the coefficient turned out to be 0 because RapidMiner could not find any effect, could not find any importance for the number of occupants, could not determine that number of occupants has any effect on the heating oil usage or the heating oil value. That's why you don't see the number of occupants here in the results of this analysis. Okay, now you have this regression model generated based on your old data. What you need to do in the next step is to apply this model that is generated based on your historical data, your training data, to your scoring data. Scoring data is data that is missing the label variable, is the data that you don't know the heating oil usage for it. So you want to use this regression equation that you built using your old data on your current data or on your scoring data in order to predict heating oil usage. Let's go ahead and do that. Let's go ahead and import the scoring data. This heating oil linear regression heating oil -S, which is the scoring data. You go next, and let's go ahead and import it. Okay, let's go to statistics, and here look at the variables. We have installation, temperature, number of occupants, average age, and home size. What is missing? The heating oil is missing. And again, this is the data that pertains to the new market. We ran a survey and we could get the information about the installation rating for homes in this new market, the outside temperature, number of occupants, average age, and home size. Now we want to apply the regression model that we built using our training data onto this scoring data in order to predict the heating oil usage for this new market. Let's go ahead and drag and drop the scoring data set into this process window. And again, remember, what do we need to do now? We need to apply the regression model that is generated using our training data set. Let me go ahead and change the name of this one to scoring data set. And let me change the name of this one to training dataset. Now it's more clear to you what they are and what they refer to. So again, we want to apply the model that is generated based on our historical or training data onto our current data or scoring data. So how can we do that? Again, remember the keyword is applying the model. So let's go ahead and search for the operator that can do this for us. Let's apply model operator. Let's go ahead, drag and drop the apply model. Apply model has two input ports. One is the model port, which you need to input the generated model. You need to feed the generated model through this model input port. And then you have the UNL port, which refers to unlabeled dataset. Unlabeled dataset is a dataset that does not contain your label or your target variable, the variable that you want to predict. Let's go ahead and connect the model from the regression to apply model and connect the scoring dataset, which lacks the label, into the unlabeled dataset. And then you will get the lab and model. So the model from apply model will pass through the model parameters and the equation into the results, and the lab will pass through the prediction. Let's go ahead and run this model, the rapid minor model. You can see the regression model, and if you go to the example set apply model, you can see the individual prediction. So here is the individual prediction for each of these homes. And you can go ahead and spot check the regression model here. What was our regression model? Let's go take a look at it. This is our regression model. How can we spot check it? Let's look for calculator. Okay, here's the calculator from Google. Let's go ahead and start with the intercept, which is 134.511. 134.511 plus 3.173, that's the intercept, multiplied by the home size. Let's go to data and see what is the home size here. This is 7. Multiplied by 7. Let's go to the linear regression again, and that's plus 1.968 plus 1.968 multiplied by the average age of the occupants. What is the average age of the occupants? Here is 70.1. 70.1. Let's go to the regression model again. Now it's minus 0.869 multiplied by the temperature, outside temperature. Which is 69. One more intercept here, and then we have plus 3.23 multiplied by insolation, plus 3.323 multiplied by insolation, which is 5. And number of occupants has no effect. Thus, you don't see it in the regression equation. Let me click on this. It's 251, 3328. It's very close. That's probably you are getting that because of the rounding up function that involves in RapidMiner, but it's essentially the same. So now you learn how you can spot check your predictions. Basically, what RapidMiner did, it went ahead and applied this equation, the model, the regression, the linear regression model created using your training data on your scoring data, and generated some results for you. Now, what was the purpose of this analysis? We wanted to be able to predict the demand for the next year. Do you think these individual predictions that know that how many units of heating oil each customer will use next year will help us in predicting the overall demand for this new market, so we can put our purchasing orders and we can plan our distribution? Well, not by themselves individually, these numbers will not help us to achieve that goal. But how can we achieve that goal? We need to aggregate these numbers. We need to add up all these individual predictions in order to understand what would be the total demand so we can plan for it. How can we do that? I just said the keyword for it. It's called aggregate. You search for aggregate and you see the aggregate operator. You drag and drop it and you connect the lab or the results, the output that generates the applied model results to it, and you get the example out. You go to aggregate, and here you can define what you want to do. You want to aggregate prediction heating oil, and you want to get the sum. You can also add more aggregation functions. You can again get prediction heating oil, and this time you may want to know the average. You click apply and you run the model again. And this time you will have the aggregate results. You know the total heating oil usage and you know the average heating oil usage per household. So you can use these numbers for your next year planning. So what if you want to see the individual outcomes again? You go here and you take the original out. Basically, it will let through the data set or the results that came to aggregate out without applying any aggregation. Now you are getting both aggregation and the original results. So here are the original results, and you can go to aggregate and you still get the sum and average as well that you can use for your next year planning. This concludes the tutorial on regression analysis using RapidMiner.